Alright, how you doing? My name is Wes LeBlanc. My topic for this week is arc welding. I had a 6-minute talk, so I'll talk to you all a little bit about that. So just a brief overview. What I'm going to do, just give you all a brief introduction on what actually arc welding is. Then I'm going to go into how it works, different types of arc welding, and the pros and cons of using it. So just an introduction. Arc welding is one of several processes for joining metals. It actually heats up the metal to really high temperature, and because of this heat, two metals actually chemically bond, and it forms a very strong bond within the two materials. So how does it work? Well, in arc welding, intense heat needed to melt the material is created by electric arc. So the arc is formed between the work material and the electrode. The electrode can either be just a rod that lets the current go to the metal, or it can actually be made out of the material that you're welding with to melt and supply a filler. So if you're welding aluminum, the electrode that you use will be made out of aluminum, and in the welding process it actually melts and can form a bond and actually can improve the weld significantly. So if you're using steel, the electrode will be made out of steel. So in order for this process to even be possible, it needs to create a circuit. So as you can see right here in the picture, electricity flows from a power source across the arc, through the base material, through the work material, and back to the power source. So it's necessary to have it grounded, and in order for this to work, it has to make a full circuit. So arc shielding. This is a process where at high temperatures, metals react chemically with the elements in the air such as oxygen and nitrogen. When metal comes in contact with the air, it oxidizes and destroys the strength of the weld. So most arc welding processes provide a covering of this arc, such as shielding gas. So what this shield does is actually eliminate the oxygen actually getting to the weld, and this gas is just pumped in, and it makes the weld a lot stronger while blocking out the oxygen. So different gases that it uses, most common ones are helium and argon, and it's just because of the cost. They're one of the cheaper ones to provide. These inert gases used in gas and tungsten arc welding. Most of these gases will cause damage to the weld in large amounts, but in controlled amounts they can actually improve the weld properties. So there's 4 main types of arc welding. First being shielded metal arc welding. This is the most common type. It's used in repair and construction work. And as sometimes you see when you pass on the road, you pass a construction site, this is the most common one. This is usually what they're doing. There's also gas and metal arc welding. This is high speed, but it's less versatile welding process. There's also flux core arc welding, and this is also high speeds and actually greater metal penetration, but it's much more expensive than the other types. And there's finally the submerged arc welding, and this is arc that is struck beneath a covering of flux, which blocks contaminants in the atmosphere and allows for a clean weld. So some of the pros of arc welding. So equipment used in the welding process is not very expensive, and it's easy to use and easy to teach somebody how to use it. Welding equipment is portable, and making it easy to use in all places. And although gas shielding is recommended, as I said earlier, it's not required, so you can actually weld without the gas shield. It just won't be as clean of a weld. The reason is widely used because it's suitable for most welding materials and alloys, so most metals do react well to it, and that's why it's the most common type. So some of the cons, the electrode that I talked about earlier needs to be replaced frequently, so it does burn up very quick, so this can be expensive by replacing these. Also the rate of deposition is lower than any of the other types of welding. And after the welding process is complete, the slag must be removed from the weld. This involves grinding or brushing off to clean up that weld. And as most of us have seen, a bright flash is given off during the welding process, so proper safety precautions must be taken. It can cause serious eye injuries if you look at that white light too long. I know it's tempting sometimes. So finally, I just want to talk about friction stir welding. This is a different type of welding. I actually got to witness some of this firsthand. My senior design team went down to Michoud in New Orleans. They do a lot of this. So it's a process of welding that mechanically intermixes 2 pieces of metal. The mixing process softens the metal, and they can be joined using mechanical pressure. So it actually mechanically spins, and it's kind of like 2 pieces of dough that are just mushed together. This thing heats it up, and it uses friction. There's no spark, there's no light or anything, and it kind of just pushes the two materials together. It actually creates a really strong bond. It is a lot more expensive than any other type of welding, and you need a machine to do it. It's not something that can be handmade, but it's using a lot of thin pieces of aluminum and things that need very high strength. So that being said, my references, are there any questions?
With friction welding, does it have to be two flat plates?
No, they can do, like when we went to visit Mishu, they was doing curved surfaces and everything. It's kind of like a 7-axis machine that can go around it. But yeah, you have to program it all in there. It's pretty cool. So. Yeah. Yep.
How does it attaches two plates?
This one? Yeah. So yeah, it's something that's pushing them together, and there's just like a crack between them, and the spinning tool goes right on top of it, and it heats up, and it kind of mixes them together. From the heat, it melts the metal, and it just pushes together and creates a bond. Yeah, it's pretty neat process. But anything else?